So, and this points to, if I cat this file now, oops, sorry, cat master, this points to the commit that the master branch on the remote is pointing to. So when you do a git fetch, what it does, it downloads all the commits, but it doesn't change your local references. It only points the remote references to the commits.
So if I don't agree with the git fetch, how I...
No, you don't have to agree, because what it does is, I'll show you. What it does is, so let's clear the history again. I love it, they should do it like that. It's much easier. So, okay, so let's say we are, we've been working, so let's say this is my local, so I'll call it local, and this is the remote. So, I'll make another history here. So this was the, this is the remote repository, so this is origin, let's say, origin, and this is the local repository, local. And this is my local master. And when I do a fetch, what it does is it copies the history. So it would copy these 3 commits from the remote and make a new branch called origin master that points to this commit here. So my local master is not changed at all. But I get some more history.
But I switch the context. Now I'm...
No, you're not. You just fetched. It just did this. It created a new branch here.
Okay, but I'm still on my local
You're still here.
Okay.
Nothing's changed for you, yeah. You just fetched some changes. And that gives you the opportunity to actually, you know, expect...
But that changes are like static. I can change to them. I can do rebase on the fetch.
Yeah, definitely. It's just a branch, but because it's in this special folder, remote branches, so we are in Git refs remotes. It doesn't treat it as a normal branch. So if I go git checkout origin master now, what it does is, oh sorry, where am I? Okay, yeah. So now if I go and say git origin master, it would actually say you are in a detached head state, because origin master is not a real branch. It's not a local branch, so you cannot modify it, you know, because this is the state of the remote's history. You cannot change your remote's history locally. The only way to do that is to push to that particular branch. So you can use it to point to commits. You can say, hey, what does origin master point to? But you cannot actually modify the reference itself because it's a remote reference. Okay. So a little bit more, force push, we make jokes about that, but there is a polite way to do that. It's called force with lease, and actually I recommend you do an alias of this. What this does is it kind of tries to push, but it first fetches and sees if the history is diverged and you don't have the history, so you didn't download the history. It would actually say, hey, there's something going on the branch, you maybe shouldn't force push because you would override somebody's changes.
And then they'll put you.
Yeah, so this is a polite way to force push. And you know, you can actually make it actually make it so you override the default force option to always force with lease, because that's much safer and you would not destroy the history.
What kind of message is this? Like, these are your changes?
Yeah, so let's try it. So I'll check out master here to get away from the default from the detached head state. So here I have I'll just reset.
You can try to push it, you will reject.
Yeah, if I try to push it, reject, but I want to reset to 20F2.
Oh.
Because I don't want the
You don't want the file?
So yeah, I don't want a file in my repository. It's too much of a responsibility to publish that. So now I try to push, and it says it's not a fast forward, so it failed. But now if I try to force with lease, it would actually accept it because I already have the actual state of the master branch of the remote.
Actually, do you? You have like...
He does have it in refs. Yeah.
I have it in the refs. But if, let's say I check out the, I reset card again. So which is this? Okay, so I check out the test branch, let's say. Okay. So now I'm on test, which if you remember is one of the two branches I made. So if I now make a commit here, again adding some file, git, okay,
The
can
test is not on remote yet, right?
file, yeah, to file.txt, now, different one. What, not cat, correct me guys. If I echo, so now git add, I added this file, and now if I commit, nice, I don't know, and I push to origin master. So you can see that I'm on the test branch, but I can still push to the master branch on the origin. So it doesn't need to match up. You can push from any branch to any. So it says rejected. Why?
The master is
Forward.
version 2.
No, this is my master. So let's fetch the origin master. Nobody else can push to this repository, so it's weird. Okay. No.
No, master is pointing to another branch.
Yeah, yeah, it's probably because, but I
But
can
another
actually,
commit.
but I can actually force push it now. I don't care. Yeah. So,
And he didn't even do it with force with Liz, right?
yeah, yeah, yeah.
He just
But
forced
I'm
it.
showing. I'll show force with least in a second. So I'll fetch it.
I didn't push it.
I didn't push it. I fetched it. Come on, guys. This is Git Panic all over again. Okay. So come on. Be serious. If
Really, you had a line that said, dude, my stash. Like, and now we're be serious.
yeah, yeah.
Our fault.
Push,
Yes. So I want to push. Okay. So I push to the origin master. It rejects it. I use force with least now because I'm a nice guy. It would actually pass this time. Okay. It uploaded the file. It's perfect. So now, but I again have the complete history. It's very hard for me on one machine in one directory to show you what the message is of force with least.
But you
because-
kind of showed it, just in reverse. Otherwise,
Okay,
you showed
yeah,
how
okay.
it was rejected before.
Yeah,
but
it
it says
was
the reason
rejected.
because you didn't have it.
Yeah, okay,
So that would be the message. It will be rejected. So.
it would be rejected, but the message would be a little bit different. So it says here it's because it's remote. It would say there are commits that you don't have that were on the branch. So here the message would be kind of different, but it would be the same idea. So now I have to fix my repository because of the videos after that. Okay, we're almost at the end, if you can tell by this bar here. Okay, so force push politely, some workflows. If you have a very small project, you can all work in master, you can rebase, that's kind of obvious. You can have team or feature branches, so I've seen both of these. Feature branches for when you're working on a single feature, team branches for when a team or several teams are sharing the repository, so each of them has their own branch and they're doing some development. They may have feature branches that branch off the team branch. You can have arbitrary complexity in your workflow. I suggest you don't. Keep it as simple as possible and talk often, communicate between your human individuals that you're in the team. And that's the best approach. And then there are merge or pull requests depending on how many remotes you have. So the difference between the merge request and the pull request is only that one is across remotes and the other is within one and the same shared repository. Okay, a little bit more. So you have merge but not fast forward. So this creates a history. So here we rebase a feature branch on top of master. And then we merge the feature branch to master, but we don't fast forward. And what this does is our history would look like this. So let's say that this is after the rebase. So I just rebased my changes on top of master, and now this is master here, and this is my feature branch here. And I want to merge but not fast forward. So that creates, if I just merge regularly, because the history is linear, it would say, hey, this is a fast forward, and it would just update my master to my feature branch, right? So it would just take this pointer and move it to this commit. But if I really want to have a merge commit for some reason, I can say no fast forwards, and what that will do is do this. It would create a history that has a split and a merge, and that's a very easy way for you to see, hey, I have several commits that are part of the same kind of lineage, and I merge them back. And that creates a nice history. If you have, for example, another commit here, that wouldn't be that great, because then you would have stuff going on both sides of the merge. But if you do that, rebase and then merge no fast forward, you would have a straight line here with no interruptions, and you have your feature branch history on this side. And that's just something I've seen for people who really want to keep their history.
That's
nice
our
looking.
workflow actually.
Yeah, so
I really like
for
this
very
work.
meticulous
It's very
people.
No, we're very dirty people.
Okay, so another thing that I've seen is tag and squash. Basically what that means is when you're here, so it's very similar, but we didn't merge. But so when you're here on your feature branch and you say, hey, I want to squash, but I still want to keep some reference to this lineage of commits here. So I create a tag here. You can create a very simple tag, just a regular tag. And I'm not getting into the different kinds of tags because I will sit here until tomorrow. So I create a tag here, and then I can squash either using reset or rebase, it doesn't matter. And I'll create a new commit that kind of squashes all of these, and my feature branch would point here, but my tag will still point here. So if I want to go back and see, hey, what was the original commit history of that feature, I still have it under the tag, but it's actually now squashed within one single commit. And I don't know why would you do that, but I've seen people do that just for show, I guess. I don't know. But maybe it's good if you have a very long feature history, feature branch history, and you have a lot of stuff in your commit messages. Some people put comments in the commit message, and you can kind of want to keep these comments somehow, and that's one way to do it. Okay. So hooks, really shortly. This is a very nice picture I found on the internet. It's CC, so nobody will sue me for using it, unlike other pictures. So these are some local hooks, and you have just a couple of remote hooks. I'll show you a couple of examples. These are very simple. They're not like real world examples really. But let's say a pre-commit hook, hooks are saved under the Git directory of your project, the hooks subdirectory, and there is a pre-commit file, or in the usual case, pre-commit.sample. And if you remove the sample and make the file executable, then you can actually run it. And here I just run, I presume it's a JavaScript project, so I run npm run lint, which will check my files for errors. I run npm run tests, which would run the tests, and if any of these two commands returns a non-zero output, then the commit would be rejected, and I would not be able to create a commit. And that's very useful if you want to make sure that you always run your tests before you commit, and that the tests are passing. Okay, so this was the pre-hook. You have a prepare message commit, which is very useful if you want to enforce or make it easy for your team to enforce a message, a message format. So basically what this hook does is you can echo any kind of text here to this S1, and this is a temporary file that would contain the commit message. So when you type git commit and it pops up with the sample message, it would actually contain whatever you wrote here. And in this case, I'm using a command called git ref parse to get the name of the current branch that my head is pointing to. And I'm saying, okay, I was on this branch here, and my message, and you should put your message here. So this particular hook enforces that your messages begin with the name of your branch.
But you can just type anything.
Yeah, you can type anything. You can type instructions to your employees. Like if you set up the hooks for anybody, you can type, hey, you're about to commit, be careful because we'll fire you if you go wrong or something like that.
Can you run some regex on the commit message.
Yeah, definitely. Yeah, you can do anything.
So
there
it's
is
basically just,
Sure.
it can be shell script or it can be anything else, like
Anything,
if it's
anything you
anything other
begin
than
the file.
SH on top,
Yeah,
like
you begin
Python,
the file
you
with
can
here,
run
you can split Python, you can Java,
so
you can run arbitrary code, you
Same-
can start
same as in-
Dockers.
same as in your shell, right?
Yeah.
So you set the hooks actually care for the output of the hook things? Is it
the
This
return
one
value,
doesn't,
the
this
return
one
value.
doesn't.
the return value? That's what
Sorry?
I was going.
Hmm?
So you set it's the output, but I thought it's the return value. And
Yeah,
That's what I thought, yeah, the return value, sorry. Okay, so this hook, if it returns non-zero, it fails. This hook, prepare commit message, it actually, you can actually use this kind of echo to redirect to the first argument, which is the temporary file. And here on this hook, which I didn't show, commit-msg message, you can actually check if the message that the developer typed, agrees with some regex or something like that. So you can prepare a message for them, and then you can check if they follow the format that you provide.
Can you make these hooks part of the repository?
There are language-specific ways to do that. So there is a Python Python thing that you install that makes it so you cannot, because the hooks are in the .git folder. You cannot actually just copy them like normal files because they're part of the Git internals. So you can put your hooks inside your project directories and use an external tool to do that. And there I've seen JavaScript tool and a Python tool and a Java tool that all do the same thing, basically. And you put your hooks inside your repository, and then this command copies them over to the actual location that they are used. Yeah, and the reason is the security one for not allowing that, because I can actually download stuff here and on your computer if you allow me to execute arbitrary hooks on, so you don't want that. You want to be safe and to actually do it by yourself. But once you set up the hooks on your computer, you only need to do that once, basically. So you can put them inside the repository, but they will be latent.
Unless you panic and delete your repository and reclone.
Yeah, of course, but that we hope to avoid that actually. Okay, so commit message hook. This is a simple server-side hook. So we saw here that these were local hooks. I'm not showing the rebase, the checkout hook. You can think of ways to use them, or you can read about how people are using them, but it's a broad discussion. What I'm showing here is, let's say, a post-receive hook, which is after the remote, when I push, after the remote has updated and everything, I actually have a hook that can check out the code. So I assume here this is a bare repository, so I need to provide an external working tree directory. So I check out in this external directory, I go to that directory, I install the dependencies, I run the build, and I restart the application. And this is poor man's continuous integration or continuous deployment. So if you're very poor, if you just have one server and you want to, do a continuous deployment, nevertheless, you can kind of do this. Yeah. So just a quick recap, and then we can get pizzas and drinks. Use the console. I showed you; it's very easy. Name remotes and branches and commits meaningfully. Keep your workflows and history understandable, and human communication is the most important. Fetch and push often, and read the manual, and make Git help you. So use it to your advantage. These are some links about useful resources that you can find whatever level you are for using Git. And of course, actually I didn't put the Git manual, but I hope you know how to find that. And the links, I will actually put it. And yeah, thanks. Questions?
Over pizza.
Okay,
Over pizza.
let's do that. Nice one.
Già si può vedere, Vigio. Un gimnasio,